Hello, welcome to my passion project, where today we're going to be investigating several chemical reactions to see just how safe they are. Something like this one, possibly even this one. Now, some of these may kill you, so we're just going to get down to the bottom of how safe they really are. This is for our AP Lang and Composition passion project, where I hope I get a good grade. Our first one is making a supersaturated solution of sodium acetate. To do this, we have to mix our baking soda, sodium bicarbonate, into our acetic acid or our vinegar. To make our supersaturated solution, since vinegar is 95% water, we have to wait for a very long time for our water to vaporize off. And as you can see here, it gets down to 400 milliliters. But unfortunately, after like a day after this, while off camera, all of the sodium acetate crystallized out, which goes to show that not every experiment you do is going to go well. Some are going to fail, inevitably. It's still wet. You know what? Sodium acetate never hurt nobody.
Famous last words.
Stir bar. As for the safety of sodium acetate, this isn't going to kill you. All of these scales are on 0 to 4. This one is 1, which means it may be an irritant. This one is 1, which means it's not flammable. This won't burn. And this is 0, which means how stable it is. Sodium acetate will not explode if you touch it. It's fine. Okay, so here's the basic chemical process behind crystallizing copper sulfate. You've got a copper ion that has a 2+ charge and a sulfate ion that has a 2- charge. And what do opposite charges do? Hey, Miss Johnson. What do opposite charges do?
Attract.
They form an ionic bond, neutralizing their charges and creating a happy little copper-2 sulfate compound. These little guys are in a strong, healthy relationship with a very strong bond. Until water comes along. Water is irresistible to the copper and sulfate ions, disassociating the compound into its respective ions. When water warms up, it becomes even more troublesome and attractive, stupid sexy water, which in turn causes more copper-2 sulfate to disassociate. We can use this fact to our advantage. By putting our sad, lumpy, powdered copper-2 sulfate into boiling water, it has a higher affinity to disassociate. In turn, when the water cools down, the copper and sulfate ions fall for each other once again, coming out of the water to form a deep blue crystal. Hello. Here I have with us LTA. And LTA, how safe do you think is copper sulfate pentahydrate really?
It's a lot of big words. Maybe like moderately safe.
On a scale of like 1 to 10, 1 being drinking water, good for you, 10 being blown up by TNT, bad for you, what do you think?
Maybe like 5.5.
5.5, okay.
Yeah.
From my conclusion, so eating copper sulfate can give you like liver failure, death, stuff like that. So what about now?
Maybe closer to like 7.
7. Okay, so basically, if you're not dumb and you don't eat it, it's really safe, and you should try it at home because it's fun. Just don't eat it.
Okay.
Any thoughts? Any final thoughts, LTA?
No.
No?
No.
Okay. Thank you for being a show guest. But all of that is boring, so let's get to the explodey stuff. Here we have potassium. Potassium has such a low ionization energy that it just doesn't want to exist. So it's going to react with the water to form potassium hydroxide, a strong base. This is only about 3 grams, so take that as you will. With way more grams, this would literally explode and destroy you. I'm Nate Copsey, and I'm here with Leo Sun. Now, Leo Sun, how safe do you think is potassium?
I don't know. I feel like it's fairly dangerous.
Fairly dangerous. So, on a scale of 1 to 10, 1 being drinking water, 10 being blown up by TNT, a recurring scale in our passion project, where would potassium fall?
I give potassium like an 8.
An 8?
Yeah.
An 8, is that in like large quantities, perchance?
I think so. Like, I think any substance, with enough quantities of it can be fairly dangerous, yes.
Do you think that amateur chemists should ever touch potassium?
No, I think that they should get more experience with other chemicals before they move on to potassium. And if they do move on to potassium, I think they should learn how to
Use
with
potassium.
a supervision.
I see. It's like a mentor.
Yes, exactly.
I see.
It's
So,
like this video.
oh, there you go.
Yeah.
Thank you, Leo Sun. It has been a pleasure speaking with you.
Thank you. Goodbye.
And for our last one, we have making a hydrogen balloon. To do this, we mix zinc metal into hydrochloric acid, which produces zinc chloride and releases hydrogen gas. We collect this gas in a balloon and then blow it up. So, without further ado, are you ready?
Mm-hmm.
Hello, I'm here with Jerry. Now, Jerry, I know you're a Vietnam War vet, and it's a beautiful day outside, so I only have one question for you. How dangerous do you think is hydrogen?
Well, with my experience in Vietnam, I think it's fairly dangerous.
Very fairly dangerous. So, on a scale of 1 to 10, 1 being drinking water, 10 being blown up by dynamite, otherwise known as cluster bombs, what would you put it at?
Well, I got to think about this.
Take all the time you need.
It's been difficult, being roughly over 50 years old. I give it a 9.
A 9.
They're very dangerous, just like Charlie out in the trees.
Is he still with us?
I hope not.
I sure also hope not. That would be awful. Hydrogen. Really something, isn't it?
Yeah.
Do you think amateur chemists should ever try using hydrogen?
I don't think so, man. I think
It's just too dangerous.
that's why I got this helmet on. I haven't drinking water because it's got 2 hydrogens, 2 of them hydrogens.
Does it?
Yeah. So just H2O. No H2O.
Out of the question?
Yeah.
Thank you, Jerry.
Yes.
I appreciate you being with us here.
Yes.
I bid you farewell on your trip to Vietnam,
Back again.
back to the good old days.
Yes.
It's really bad. Don't look at it.
Hey, this is a class.
Are you vlogging right now?
Hi.
You see that? That's chemistry at work there, bub. Oh, the face you're making. Oh man.
I don't think you could have gotten it any closer to overflowing the gas.
Well, I'm not gonna put that much in at once now.
Duly noted, yes.
This is a video.
Yeah, I can tell.
Do a funny face.
My face is always funny.
That's
I'm,
true.
I'm just funny looking.